So what I'm going to do, these were your questions, 8, 9, 10, 11, 12, 13, 14, up to 15, I think. So I will give you the answers. If you have gotten the correct answers, we are fine. That means if you have any doubts, or if you did not get the correct answers, you let me know, and then we can discuss. Okay. So starting with question number 8, I will show you the answers one by one. Okay. So for the 8th one, is this right? So I've taken the answers from the booklet answer at the back of the booklet, but there was this might be, it's right, okay. I thought there was a missing 0 in this, okay. So did everyone get that? X is 0.802. Anyone didn't get this? Okay, since you're silence, I will assume that you all got this. Okay, number 9, X is 0.481. Correct? Oh, give me a moment. Sasindu is saying he can only listen. I didn't have the writing book. Okay, Sasindu. I don't know how effective that is. Anyway, I can send you the recording later then, okay? Yes, Hatvi. So Kavidi wants me to do it. And then Hatvi, what's the issue, Hatvi? Different order. What do you mean? So these are the question number 8 and 9, the ones I showed you. Like I may have sent you the second, I sent you in 2 pictures now. So I'm going in order. They were this 8, 9, 10. You see the question numbers here? 8, 9, 10, 11. And then these now, 12, 13, 14, 15. Right? 8, 9, 8, 9 up to 11. All these were there, not just 8, 9, isn't it? I may have sent it in the reverse order in the WhatsApp group. Okay, right? So I'm giving you the answers in order. So is the, okay, and now Kavindi wanted me to do this. Is my answer correct for number 9? Is my answer correct for number 9? Can someone quickly tell me? Correct. Okay, Netni. So you got the answer, right? Okay. So for Kavindi, let me go to the question and copy it onto my writing pad. Number 9, solve correct to 3 significant figures, the equation. So this is Kavindi, an exponential equation because you have x in the exponent. I can see why this may have been challenging for some of you if it was. Let me copy the question first. We have y, so e to the power of x plus e to the power of 2x equals e to the power of 3x. Okay, Kavindi. Now when you look, so for the first thing you will notice is that there are 3 terms in which you have x in the power, and all 3 terms are exponent in the exponent form, and the base is e. You know that e is just a number, right? Don't worry about e. Don't get scared for e. Just think that it is 2 or 3. Like in your mind, put your favorite number in place of e. Don't be bothered because of having E, because having E might give you the sense of there is another unknown, like, because it's a letter. Okay, but it's just a number. Please remember that. It's like pi. It's a letter that we use to represent a number, because that number is irrational, because you can't write it down properly, right? So it's like, this is like 2 to the power of x plus 2 to the power of 2x equals 2 to the power of 3x. It's something like that. So, okay, so whenever you see E, please remember that. It's just a number. Right, now how do we know? Let's think about this. So x is in 3 different terms. And the other thing you have to notice is, so the power goes first x, and then 2x, and then 3x. Kavindi, what did you try? Tell me. So how do we think about this? How do we approach this problem? What do we do? Kavindi, can you tell me what you thought of doing for? Like, was there anything that came to your mind? Oh, so immediately as it is. Now I will show you what will happen. So what Kavindi has done is raising both sides to the power of ln. Now a very good thing I notice here, because you have correctly identified, because the base is E, you have to raise to the power of ln. So that part is correct. But the problem here is, remember, before you raise to the power of ln, you have to have just one exponent term and one exponent term or number. One term on both sides. Now go back and check all the exponential equations we solved. We raised the 2 sides to log or ln or whatever when we came to a point where we had one term equals one term. Otherwise, raising the 2 sides to some log or ln wouldn't help you. Now let me show you. Let's do what you're saying and see what happens. I'm going to raise this whole side, because this side has 2 terms, right? There is a serious lagging today, isn't it? And then this side is okay. That's just one term. So let me raise. This is what I would get. Ln in the power I will have. Now I doubt whether this will help me. E to the power of x plus e to the power of 2x. This whole thing is in the power, okay? Equals ln e to the power of 3x. Now, does this help me to simplify anything? Let's see. Left hand side, of course, sorry, right hand side, of course. The ln and the e, inverse operations. And then I just get 3x on this side. Here what happens? How do I know how to simplify something like this? Log or ln, some log to a power, and there is a... Oh, Mihil, okay. What do you mean? So do you not see, like...
Miss, I came, I joined by my phone, my mom's phone.
All right, did you just join?
Yeah, miss.
Okay.
Sorry for it.
Okay. It's okay, Mihil. Thank you for letting me know. So we started discussing the homework. I gave the answer for number 8. We are on number 9. I'm explaining number 9. Do you see, Kavindi? Do we know how to simplify this? Like, if I just had one term, that's why I said we need to have one term. Like this, if you had ln to the power, oh wait, what are we doing? Raising to the power of, my goodness, this is wrong. You can't raise to a power of ln. Ln is not an, I also blindly just did what you said. It has no meaning. Raising to the power of ln. Ln is not a number. You can raise something to a power of a number. 2 to a power. Ln is not a number. It's just the name of it's just an operation. You can take ln on both sides, not raise. Is that what you meant, Kavindi? This is completely wrong. Even I didn't realize it until now. I just kept doing it. Kavindi, I think this is what you meant. Take ln on both sides like this. Is that what you meant? Not raise to the power. Now you can raise something to a power of, the base has to be a number, no? Like raise both sides to the power of 2, raise both sides to the power of 3, raise both sides to the power of e. Ln is not a number. This makes no sense. I'm very sorry. I also just, okay, that's wrong. You can take ln of a number. Ln of a number. So this is correct. Ln of something. Okay. But then, okay, so again, so this side, this is wrong. This side, ln of e to power. So these two cancel off and you get 3x. That's it. That is correct. Here, do we know how to simplify? Ln or log of sum of two things, because you have sum of two things. Do we have a rule in our log rules? We have a set of log rules. Do we have a rule there that tells us how to simplify something like this? What is log a plus b equal to? Do we have a rule like that? If we have, we can apply it here and simplify this. We don't have anything like that. So the problem in taking ln on both sides is, there's nothing wrong in this step. There's nothing wrong. You can do that. But it doesn't help you to simplify this because we don't know how to simplify this side. Okay? So please remember, taking ln on both sides and even raising to a power. Now, let me fix this first, okay? When you have an exponential equation in which x is in the power, you take ln or log, the appropriate one, on both sides, not raise. This is a raised equation. To bring it down, you take ln. You just say you take ln. You take log of this side, log of that side. When you have a logarithmic equation, to get rid of the log, then you raise both sides to an appropriate base. To cancel log, you have to raise. To cancel something that is already raised, x is already raised to a power of e. You don't raise it more. You take log in order to, in the hope of bringing it down, because log is the reverse of raising something to a power. Is that clear, Kavita? Now we still didn't figure out how to do it. I just showed you why your suggestion doesn't work. So it doesn't work. So we are back to this again. We are still in the first step. What else can we do? What else comes to your mind? What else can we do here? Someone else tell me. So let me write it again. Okay, yeah, Hatvi is right. So let me write it again. E to the power of x, e to the power of 2x is equal to e to the power of 3x. Because we have this power x, power 2x, power 3x, it's like, you have to say this. If I relabel, remember quadratic equations in this, guys? We relabel something, then it becomes something that we know or we are familiar with. Remember that as a technique. That can be used anywhere in your mathematics. Like, don't restrict that strategy only for quadratic type. This also looks like a bit of a quadratic. But remember that as a technique. Do you see that this is everywhere e to the power of x? I mean, like this I can write. Let me break it down for you. This is actually e to the power of x plus this I can write as e to the power of x squared. Is that right? Power, when you have power, these are exponent rules. When do you multiply powers? When you have power of a power. So this 2x I can break down as e to the power. There are two ways I can break it down. 3 to the power, e to the power of x to the power of 2, or e to the power of 2 to the power of x. In any order, I can break them down. It's a power of a power. That's when you multiply the powers. So when you see a product in the power, this has to come to your mind that you can write it this way. And I purposely, with a certain aim, I purposely put e to the power of x first and then to the power of 2, because I get everything in terms of e to the power of x. And then others, this I can write, this is actually e to the power of x cube. Is that clear? What I just did there? 3x means 3 times x. It has come from a power of a power. Okay, then I can do a little relabeling. Let me relabel e to the power of x with one letter. So say let us call e to the power of x. It's just a relabeling. I'm using the equivalent sign. I'm just relabeling. I'm just labeling it with a different letter. I'll take t. Then this equation turns into what? T. This is t then. This is t squared. And that is t cube. Okay. Now it's an equation of t. So we turned it into a different equation. But doesn't it? It looks simpler now, isn't it? Because now, so let's solve for t. And our t is in the base. This is t. It's a cubic equation. How do we solve this? What can we do? Shall we bring everything to one side and try? How do we do this? Is this the same relabeling you did, Hatfi? Now all of you have to think and you have to talk with me. I want to hear how you're thinking, what comes to your minds. Because that only I can nurture or like shape or, I can help you in your thinking if I know how you're thinking. Now what to do? Now does this help now? I don't know. Does this help us, or even maybe this doesn't help us too? Let's see. What do you think we should do now? You have to talk. Somebody. Shall we try shall I bring this to this side? Extract t? What do you mean? Now there is no mathematical term called extract. Did you mean factorize t or factor t out? Yes. From this, or do I bring, now it's a cubic equation, right? You know how to solve quadratic equations. The key to solving quadratic equations is to have all the terms on one side and have 0 on the other side. For any higher order equation, so this is a cubic, that's the strategy. Let's bring the t cube also to this side so that we can factor t out. 0. Right? And let's factorize, because factorizing is how we solve quadratics. Let's try the same method here. If I factorize a t out, I get 1 plus t minus t squared is equal to 0. Now I'm sure you can continue from here. What can I say now? I have factorized this into 2 factors. I can say that t is equal to 0 or 1 plus t plus, 1 plus t minus t squared is equal to 0. Either this must be 0 or that must be 0. The same argument that you do in quadratics. Tarindu, what I say? Can't we take the 2 to the opposite side? For convenience, which two? Two to the opposite side? The two t terms. These two t terms to the other side. Yeah, same thing now. Yeah. One of the sides. You have to collect or have all the terms on one side and have 0 on the other side. And for that, you can either bring this to this side or take both these to the other side. That's your choice. Both ways are correct, right? I know why you are thinking of doing that, but both ways are correct. So now here, I can continue solving this. Now I have solved for t. T is 0, but t is something that I took. What is t actually? T is e to the power of x. So let me bring that back here. What I have gotten here is that e to the power of x is 0. Now I can solve this. Kavindi, now you can take ln of both sides, not raised to power of ln. That doesn't make sense. That statement makes no sense, right? You take ln on both sides because I have one thing equals one thing. When you have one term and one term, only doing that would get you somewhere. So now I can take ln of this and ln of that, e to the power of x and 0. I took ln of both sides. Then here, so I'm still dealing with one equation. I have another equation to be dealt with later here. That is a quadratic, and surely you can deal with that too. What do I get here? Ln and then e to a power. So these two undo each other, and then I get just x here. And what is ln 0? Ln 0. Now you have to be able to quickly say about ln 0. No, Kavindi, ln 0 is not 0. Can you all quickly visualize the ln? Let me say log. No, Hatvi, it is not infinity either. No, Tharindu, it's not 1. Yes, Hatvi. I will not say, yes, Bhimandi. Can you all visualize the log graph in your head? Do you all see the log graph in your head? All of you, visualize the log graph. Let me draw the log graph for you. No, these have to be like, you have to be really, where do I want to take you? Give me a moment. I have to first, I'm going to draw the log graph for you. Can I just quickly, give me a moment to quickly open Desmus. I can properly show you. Okay, let me, now where are you? You're here. Let me take you there now. What? Somebody saying something? Asymptote? I just, wait, I didn't see that properly. Hati says because of the asymptote. Okay, let's see. Yeah, what do you mean by asymptote? No, here it is. Y equals, let me do log x. So that means log base 10. Now, I am going to zoom this in. This is how the log graph looks like. Okay? It goes like that, keeps increasing that way infinitely. It goes like that infinitely. It doesn't flatten up. It's going up like that. And here it crosses the x-axis at 1. All log graphs, whatever the base is, they all cross the x-axis. X-intercept is 1, and then it goes down like that. It looks like it goes and gets parallel and touches and lands on the y-axis. That's how it looks like. Let me zoom this in. zoom in, zoom in. I just want to see where it touches the y-axis. So I'm gonna, does it touch at like -2? Let me zoom in more. Oops, zoom in more. No, zoom in more. Oh, no, it hasn't touched yet. So let me go down. Where does it touch? Where does it touch? Is it touching here? Is it touch? I'm going down, okay? It's getting very close. Let me zoom in further. I'm going to zoom more. It hasn't touched yet. I'm going further down, further down, further down, further down, further down. Further down, further down, further down. How much longer do you think I would have to do this? It's getting closer. It's further down, getting closer. Looks like I can find where it's in, because I want to find what log 0 is, like log 0 or log 0, right? So I'm going to see log 0 means when x is 0, what the y value is. So this is what I'm trying to do. It's getting closer. It's getting closer. Now somebody can say if you want to say anything. Now some of you already said that. If I zoom this in more, do you see still there is a gap? So actually we have talked about this. Okay, this your log graphs, they go like that. So this is the x-axis. They go like this, and then it keeps approaching the y-axis, but never touches it. It keeps getting closer and closer and closer and closer. And it might be very difficult for you to think, how is it possible? If it is getting closer and closer, eventually it has to go and touch it. No. However much I go down, I can zoom in to say there is still more. There is still more. Creepy, yes. This is only possible in mathematics. It's just, I mean, you can't draw it with a pen, because the thickness of your pen would when you keep, because it is getting closer. Then if you try to draw it with your pen, when you make it closer, you are going to go and touch the y-axis. But theoretically, this line should be of no thickness. It's just a line, right? And then you zoom, it never touches. So we say that the y-axis, the mathematical term that we use to express this thing, that weird thing that is happening, it's getting closer to a certain line but never touches it, or like to cross it first it has to touch it. So it doesn't touch it, but it gets closer and closer to it, is the word asymptote. We say that this y-axis is an asymptote to this graph. That means the graph gets closer and closer to this line, but never touches it, which means there is no log 0. There is no coordinate for that. You can't find on this graph where the x coordinate is 0. It does not become 0. Do you understand what I'm saying? So remember the domain of log graph. X is greater than 0 because it never becomes 0. For x to be 0, the graph must be on the y-axis. X is 0 on the y-axis, right? But this graph doesn't come onto the y-axis. Do you understand? So this has to be something very significant thing that has to stick in your head. So when you see log 0, you have to know, that's not defined. There is no log 0. You have to know that, okay? So now I spent a lot of time showing you that in the hope that this will stick in your head forever now. Log, it's blur, isn't it? Log any base of 0, there's nothing like that. It's undefined. So this has no solutions. That part give us no solutions. Okay. So let's try to deal with that. Now, can I leave you to complete that? It's a quadratic. So you will factorize, and before you factorize, because the t-square is negative, you would take everything to the other side. That's why Tarindu suggested to take all the terms to the other side in the beginning itself. That's fine. So, or you can just swap the signs throughout here. So this is t squared minus t minus 1 equals 0. You can factorize, and again you will get two answers, t equals something and t equals something. And you bring your e to the power of x back here, e to the power of x is something, and e to the power of x is something, and you take ln on both sides in that, and then find the answers. So do you only get one answer? Shall we just actually do it? What are the -1? This doesn't factorize. Does it have factors? No, it doesn't have factors. So you have to use the formula. Sorry, this you can't factorize -1 to two numbers that add up to -1, right? So you have to use the formula and get the two answers, and they will come here. So I will cut this line off. You use your calculator, input A, B, and C, and get the two answers. One answer will go here, the other answer will go here, right? And so you get, let me write. So Hatfi is giving me the answer. You get 1.62. This is, shall I go to a new page? Hatfi says, you get e to the power of x t equals 1.62 and t equals minus 0.62. So you would write e to the power of x equals 1.62 and e to the power of x, this is not, and this is or this or that. We get two possible answers, minus 0.62, and when you take ln on both sides, here you get just x, and this you can find from your calculator. On the other side, when you take ln, again, this is x, but what can you say about that? What can you say about this? Visualize the graph. Does your x domain, are there any x values negative side? Do you even have the graph on the negative side? Any negative x values? No, makes no sense. That's not defined. The log function, in the log function, the numbers that can go into a log function are only positive numbers. No negative numbers can go into it. 0 can't go into it. Only positive numbers can go into it. Whenever you see log of a negative number or log 0, that those are not defined. There's nothing like that in this universe. It's not there. Non-existent. So that doesn't give us anything. Is it clear, Kavindi? Now, I spent a lot of time on that question just to make it clear to you, and because even last week, that last question I gave you, y'all couldn't do it properly. So I was really, it kind of worried me a little bit, not a little bit, actually a lot. So yeah, okay. Kavindi, is that okay now? Do you have any more questions to ask? Please now engage your thinking with this. You have to have questions. I like when you're welcome, Kavindi. You understood, right? If you don't understand any little point, just ask, okay? And any what if question, just ask. What if we do this, miss? You can ask anything like that. That's what needs to happen. Then only you will learn this, how to think on your own. Feel free in your mind. Okay? Okay, if that is clear, then let's do number 9. Number 10. So number 10 answer I will give. Oops. Okay. Is that correct? Number 10. X is equal to 0.313. Okay. Did everyone get this? I want to see, is everyone here today? Okay, Rachel got it, very good. Netni got it, Hatfi got it. Can you, Bimandi, that is what I have, 0.313. That's the same thing, 313. Correct. Right? What about Joanne? Nathan is just entering. Let me quickly answer Nathan. Nathan is messaging me on the WhatsApp group. Nathan is messaging. Yeah. Okay, Joanne got it too. Nice. So everyone got it right. Now I will keep telling you this. I completely rely on what you tell me. I trust you. If you are silent, then what does that indicate? That you all have gotten that answer. If you haven't, you have to tell me. Okay, then I can help you. I can do it and show you. So please do that. Right. Okay. So if 10 is okay, then number 11, let me quickly show you number 11. What is number 11? Again, it's a ln equation. So it's a logarithmic equation. Number 9 answer, number 11 answer is x is equal to minus. Oh, wait, Bimandi has got for number 10, 4.839. Shall we quickly look at it then? Number 10. Number 10. Let me quickly copy it. Number 10, we have, let me copy it here. Ln x plus 2 is equal to 2 plus ln x, right? Okay. Hopefully got the same answer as I did, no? And all the rest of you. So let me quickly show you. Let's see where Bimandi has gone wrong. Nathan, we are discussing the homework. We are on number 10. Okay, so you start checking from number 10 onwards now. For the rest, you can, I will send you the recording. Okay, so, okay, Bimandi, we know what to do. All the ln terms we have to collect on one side so that we can simplify them to a single ln term. So the first step, I'm sure that you all have done is taking this ln x term to this side. So I get minus ln x. Let me put the x also in a bracket so that is clear. Now I have a rule that I can apply to combine these two. This has the form ln a. If I call this a and if I call this b, I have a rule. Let me write that rule in the middle here, because last time you had trouble with this rule. What is this rule? If I will write it in general for log. I will say log. If I have log a plus log b, that means if I have the sum of two log terms, then I can simplify it to log a times b, and vice versa. If I have that, I can break it down into log a plus log b. Or when I have the sum of two terms, I can combine them into a single log term, log ab. So this is the rule I'm using. So I get here ln this times that, right? So let me put a big like a square bracket. X plus 2 times x. Now I have a single log term, right? Equals 2. Now you raise both sides to what power? Power of e, because you have ln here. You raise both sides to the power of e. So e to this power, now I didn't really simplify that what's in the bracket, okay? So on this side, these two operations, they are inverses. So they, I mean, there is something here. You have taken the ln of it, and then that has been raised to the power of e. Then that gets cancelled and you are left with x plus 2. Bimandi, so far, is it right? Then e to the power of 2 is just a number. Bimandi, up to here, have you gotten up to this step? X plus 2. Oh, sorry, it's minus. Yes. Now, why did anyone not correct me? Yes, Bimandi, it is. So no one is paying attention. You can't just blindly observe very passively. Just observe like spectators what I'm doing. You can't just watch. You have to engage. If you were engaging actively, you should have noticed I made a mistake. This is not plus, this is minus. Which rule should I? Thank you, Bimandi. Did anyone not notice that? Do I have the sum here? I have a difference. I have a difference. This is stuck. You can't, right? Difference, not sum. So the difference rule, this is the sum rule of log. What's the difference rule? Let me try to squeeze that in here, different color, and put another box. Let me put it here. If you have log A minus log B, then that is equal to log A over B. A over B. This is the difference. This is the sum. If you have a sum, you can simplify like that. If you have a difference, you have to, difference is A over B. Hi-yo. Now I'm going to jump, okay? I'm going to jump. Now you have to, so finally what you're going to get here is x plus 2 over x is equal to e to the power of 2. So you correct these steps. I'm disappointed in you because you didn't notice my mistake. I don't know whether you have fallen asleep there on the other side. Okay, so Bimandi, is it correct up to here what you have done? I'm trying to see where you have gone wrong, right? And then you cross multiply, not cross multiply, multiply both sides by x. And then, okay, so let's see, then let's bring the all x terms to one side. And let me take the 2 to the other side and you factor the x out. I'm kind of doing this quickly now because now it is a simple equation. From this point onwards, this is O-level work. O-level. Okay, so I'm doing fast. 1 minus e to the power of 2. So divide both sides by 1 minus e to the power of 2. Is this what you got? And then you just input this into your calculator. And is it not 0.313? Yeah. Bimandi? Okay, Bimandi. Oh, you haven't squared e. So, because both sides you raise to the power of e, na? Right here, na? There is a big lag. I have to fix that. I don't know why that is happening. That is not supposed to happen with this app that I'm using. This when you raise both sides to the power of e, you had 2 there, so e to the power of 2. Okay. So that's just a mistake. No, that's a careless mistake. Okay, here's number 11. Answer. Minus 1.68. Minus 1.68. Correct, Happy. Very good. Others? Let's try to hurry up. Okay, you have to quickly respond. Then we can do this a bit faster. Nathan. Nathan, now I think I have already answered this question a couple of times. If they have, now Nathan is asking whether to keep the answer to 2SF or 3SF. I'm sure I have talked about this before. If not specified in the question, you always give your answer to 3SF. Please remember this. If not specified in the question, if they specify to a certain degree of accuracy, you give it to that degree of accuracy that they want. If they haven't specified, then you leave your answers always to 3 significant figures. So minus 1.68. Okay. Good. So now everyone got this. Looks like. You're welcome, Nathan. Okay, then number 12. Number 12, you get 2 answers.
Excuse me, miss.
Yes,
can you do number 11, teacher?
Number 11. So you didn't get this. Can I? Okay, let us go and see what the question is. Is it a log equation or an exponential equation? Which one was that? Number 11, let's see. Number 11 is a log equation. Okay, let's quickly look at that too then. Let me first copy the question into the writing pad. This is number 11. 12 is right, Happy? Okay. Good. Number 11. You have ln 2 plus e to the power of minus x equals 2. This is very easy. This looks very easy. I'm wondering why, Nathan, this, okay. Why do I say this is very easy? Because there is nothing to do, no preparation. You already have the equation that is given to you, already have one term and one term. Usually you have to, if you have a couple of terms, you have to take all the log terms and combine them into one log term. Here you only have one log term, right? A single log term on this side, log base e, that is ln, and then a single number on the other side. So you, what do you do? Nathan, what do you do? When you what do you do?
Was this, how do I say this? I have to, was this, write that this ln term as the power to e and the e to the power 2 on the other side.
All right. So is it like e to the power of 2 like this?
Yeah, e to the power 2 is on one side, and the other side also e to the power of ln that thing.
You mean, okay.
No, sorry, miss. Just
no.
have, can, okay, miss.
Just say it.
No, this miss, you were going to do straight away to the point, no, miss. It's okay, you can continue, miss.
No, I want you to tell me what to do.
Okay, e to the power ln bracket 2 plus.
So the way you say it is, you raise the two sides, you lift them up, right? You raise it. So like, how do you say you raise 2 to the power of 3? That means 2 to the power of 3. You raise 2 to the power of 3. That's the terminology that you used to say it. So you raise these two sides to the power of e. Yeah. So
okay.
Nathan, did you do that?
No, miss. I now I realized my mistake.
All right. Okay. So okay, nothing. That is like very straightforward.
when you said that it was very easy, miss, then only I realized. Yes, miss. Otherwise, I went in a different route. I thought like this would include some complicated working and stuff.
Okay. So if you know, like, so as I said earlier, you weren't here when I said that I was explaining something to Kavindi. In both types of equations, logarithmic equations or exponential equations, when you come to the point where you have one log term equals one number or one exponential term equals one number, then you do the reverse. For the log equation, you raise to some power. With the exponential equation, you take log. So that's the strategy. And then in that particular equation, number 11, you already have one log term and one number, and then you raise to that power. And just go ahead and solve. So number 12, Hatri is saying the answers are right. We have to hurry up, like for 1 whole hour is gone just for, but this is okay. I mean, I'm not complaining that we are still, no, this is all good. This is how you have to do it because we did not solve enough questions in this topic, right? So this is part of the lesson. So any questions from number 12? Good, Netni. So Hatri got the answers, Netni got the answers. I have not been hearing from so Sasindu is just listening, I think. Sasindu is listening to our lesson on his way from somewhere. Joanne, Mihil, you got this? Malit, are you here, Malit? Malit has been really quiet.
Yes, miss.
Okay. Are you okay today?
Yeah, I'm a little tired. I just finished physical classes and came, that's why.
Oh, okay. Okay. Okay, so looks like everyone got this, right? We can, Viband is asking, we can, what? Can we take, what are you asking, Vibandi? Not clear. Vibandi? Now both, there are two answers. This or, actually not a comma, you should say this or this. Sasindu. Okay, Sasindu. Yes, Vibandi.
Miss, when we solve the equation, like when we put 3.62, I got 0.32208 and 0.3229.
What do you mean? Let us go to the question. Number 12 now. This question. What are you saying? Say it again. So now you solve this and it turns into a quadratic equation, right?
Yes, miss.
Yeah, and aren't these the two answers? 1.38 and 3.62.
Like miss, we can check, right? We can put the x value to the equation and check.
Yes, whether it fits. Yes.
Yeah. So then when I did that, for ln 5 minus x, I got 3.2208.
Okay. Yes, and let me tell you why that is. Let me tell you why that is, okay? Now, that's a good point that you are raising, Bimandi. Now, Bimandi has gone and checked her answers too. Now, I mean, when you solve an equation, you can always make sure whether you don't have to wait for someone else to come and check your answer. You can check it yourself whether you got the right answer or not. How? Because if your answers are right, when you plug them back into your equation, it has to fit into it. The two sides have to balance with your numbers that you put in. So you can substitute and check. So what she's saying is, when she tried that with this answer, the two sides were not exactly the same. That's right? Is that right, Bibandi?
Yes, miss.
That's because, Bimandi, for this x value, was it exactly 3.62 or was it, did it have more digits and you gave it to 3 significant figures?
Yeah, like it was 3.618.
618, right? That's why. So you have to, when you check back, now you give the answer to 3 significant figures because they want you to give to 3 significant figures. The accurate answer is whatever the accurate answer you get. If you check with that, it will correctly balance. Okay. I hope that is clear. Then number 13. X is equal to 0.585. This is right. 13th. Quick, hurry up. Is this right? That feedback has to come quick.
Yes, miss, it's right.
Correct. Good. Thank you, Nathan. Number 14. X is equal to 0.763. Correct?
Miss, I might have made a silly mistake there, but now that I did it again, it's correct. Yeah.
Okay. Okay. Rachel says it's yes. Okay. Good. And the last question. Now, anyone, please stop me and ask if you have any question. Last one has 2 parts. Number 15. So part 1 is you have to show that you get this quadratic equation. So that's the equation you get. And then when you solve it, you get these 2 answers. Okay, Hatri says correct. Others, everyone else is okay with that? Okay. Now we do have to, okay, Rachel, we do have to practice a lot more questions from this topic, logarithms and exponential functions. So this week too, I'm going to give you another set of questions from the booklet as homework for next week. We can start the 3rd topic in P3, which is trigonometry. Okay, we can start it now. Is that okay, or do you want us to do a few more questions in class from this topic before we start trig? Or is it okay if I give you...
Miss, could you do a few more sums, miss?
In class? Or I can
Yes,
assign
miss.
you some for homework.
I can some for homework. That's okay.
Which oh, last
Any
one
method,
wrong.
miss.
Wait. Hatfi is saying last one is wrong. Which one, Hatfi? What, like last one means part 2, 15 part 2, the second solution. Can you specifically tell me which one you are referring to? Which one is wrong? But Netli, Rachel, we got this. You got these answers, right? Oh, minus. Oh, this is minus 3.5. Hatri is saying that it should be minus 3.68 or okay, plus 3 points. So this is correct, he's saying. Other one, it's my oh, it should be minus. You mean, so where is the minus sign here? Where it should be minus 8.68. So the answer to this, I mean, when you work this out, can you plug in value in formula and check? Yeah, I can't use my, yeah, did we have a log equation? If the equation that we were solving was a log equation, and you have log x in that equation, we have to, yes, this is number what? 15. Let me check. Okay. So we have log x here. So our x can't be a negative number. So if you do get a negative number here, I don't think this was did you all get a negative answer for the second answer? If you do get a negative answer, yes, you don't accept it, you reject it. But do you not, I don't think this is negative, this is positive. I can't plug this in. I don't have, I'm ashamed to say this, I don't have a calculator. It's the 2 ways to write the correct answer. Yeah, can someone who has a calculator, plug this thing that I have in your calculator, this what is in the circle, and tell me what you get? Someone who has a calculator right now. $3.6. Oh, sorry. That's what you were saying, Nathan, isn't it? So, I mean, it is only one answer. Yeah, thank you, Nathan. It is only one answer. It is this. You can write it this way or that way. It's the same thing. So, from this, you get 3.68. The point is, if in the exam, if you leave your answer like that, still they give you the answer. So, I should have written, I mean, like that. This or this you can write, not two, it's not two answers, it's the same answer. And you do get a second answer, it's a negative answer and you reject it. This -8 answer you reject. Okay? Confusion there, no? Because I gave you like 2 answers. Yes, okay, happy. So are you all okay with the second option? That is, I will give you some more questions from logarithmic and exponential functions for homework, and we start trig now.